Hello, in this session we're going to look at the factors affecting the rate of reaction. Now, the rate of reaction is defined as the time taken for a product to be formed from its reactants. It's also the time taken for a given reagent to be depleted in order to form a product during a chemical change. What then are the factors that affect the rate of a chemical reaction? The first factor, which is the most cardinal that affects the rate of a reaction, is the particle size, otherwise referred to as the surface area. The smaller the particle size, the larger the surface area of contact, and that provides a means for effective collision of particles. And therefore, we find that particles which are smaller in size will react faster than those which are larger in size. Let's look at a typical example where we have calcium carbonate. Calcium carbonate may exist in form of marble chips. Now, when marble chips interact with HCl, the reaction is very slow, simply because the surface area or the particle size is large. Number two, when calcium carbonate is in powdered form, it may exist as limestone. So limestone is a powdery form of calcium carbonate. In that case, the reaction is fast. And being relatively fast, by virtue of having small particle size, which increase the chance for effective collision, then we can say that the particle size influences the rate of reaction. The second factor that affects the rate of reaction is the concentration. We may have reactants in dilute state and others in concentrated states. Let's say, for example, nitric acid. When nitric acid is in dilute state and meets copper, the reaction is relatively fast, in the sense that when the acid is dilute, it's made up of free or delocalized ions, because the presence of water in the acid separates the cationic part from the anionic part, and when the reagent is added, such as copper, it will attract readily to the cation and form the product, and the reaction ends up being a fast process. When, however, the acid is concentrated, which means it is molecular in form, it does not have free or delocalized ions. Therefore, it takes an uphill task for the attacking agent to break the bond between the hydrogen and the nitrate in the nitric acid in order for the reaction to proceed as required. For that reason, the reaction of the conc solution becomes slower. And therefore, you can see clearly that these two reactions may seem to be similar, but their rates are relatively different. Number three, temperature. Whenever temperature is added in a reaction, it will affect the reaction depending on its nature, whether the reaction is heat absorbing or endothermic, or whether the reaction is heat releasing or exothermic. Whenever a chemical reaction is endothermic, it will infer that the addition of high temperatures will enhance that process. When, however, the reaction is exothermic, which means releasing heat, the requirement will be of lowering temperature. Therefore, we can say comfortably that a reaction in which a product is formed and bonds are formed will be exothermic. That reaction will be favored by the lowering of temperatures. A reaction in which bonds are broken, such as the sulfur trioxide changing into sulfur dioxide and oxygen, is endothermic. Endothermic in the sense that it absorbs heat. Therefore, increasing the temperature in the endothermic process will enhance the process. Lowering the temperature in the exothermic process will also enhance that process. If, however, the reaction is exothermic and you happen to increase the temperature, then you will be reversing the process and the reaction becomes slower. The fourth factor which affects the rate of reaction is pressure. Now, all chemical reactions do not occur until all the reagents have been transformed into gaseous state and ionized. Therefore, we can say that pressure will affect all chemical reactions. However, the pressure increase will enhance the process that leads to a reduction in volume. Let's take, for example, nitrogen combining with hydrogen to form ammonia. When nitrogen combines with hydrogen, according to the Gay-Lussac principle, the reaction is in the mole ratio 1:3 and forms 2 volumes. The net result is that there are a collection of 4 volumes reacting and 2 volumes forming. Therefore, to be able to change 4 volumes to 2 volumes, pressure has to be increased. If, however, pressure is lowered, that reaction process will be reversed in the sense that there will be an expansion of the volume from 2 volume to 4 volume. Therefore, in the Haber process, where nitrogen combines with hydrogen to form ammonia, if pressure is increased, the forward reaction is enhanced, forming ammonia exclusively. And if pressure is decreased, then the backward reaction is enhanced, leading to the formation of nitrogen and hydrogen by the breakage of the ammonia bond. The fifth factor which affects the rate of reaction is a catalyst. A catalyst is simply defined as a substance which speeds up the rate of reaction without itself taking part in the chemical change. Let's take the example of hydrogen peroxide. When hydrogen peroxide decomposes, it decomposes naturally, forming water and oxygen gas. The reaction is relatively slow. When, however, we introduce a catalyst in the form of manganese 4 oxide, the reaction becomes faster, and we change the superficial conversion of hydrogen peroxide into water and oxygen into an aided process by the catalyst. The sixth factor which affects the rate of reaction is light. Now, light is an agent which is effective only in photoactive processes. And amongst photoactive processes is photosynthesis. In photosynthesis, carbon dioxide combines with water in the presence of ultraviolet light from the sunlight, which leads to the formation of sucrose or starch and the emission of oxygen gas. Photosynthesis will not occur in the absence of the ultraviolet light from the sun. The same way, when the alkanes, which are saturated hydrocarbons, interact with the halogens, the net result is that the reaction does not occur unless there is ultraviolet light. What then is the role of ultraviolet light? The ultraviolet light has a role of breaking the halogen bond in order to change it from a molecule into atoms. The molecule of halogen are relatively inert, while the atoms are active since they have electron deficiency in the outermost electron shell or the valence shell in that respect. And therefore, we can say that light will affect the rate of chemical reaction so long as the reaction is photoactive. In summary, therefore, there are 6 core factors which affect the rate of reaction, namely the surface area, which is determined by the particle size, and the smaller the particle size, the faster the rate of reaction. Secondly is the concentration, and we have seen that dilute solutions are reacting faster than the concentrated solution. The third is the temperature, and we have seen that endothermic processes are enhanced by increasing temperature, while exothermic processes are enhanced by lowering the temperature. The fourth factor we have looked at is pressure, and we have said all chemical reactions will be enhanced by pressure increase if the end result is a reduction in volume. However, if the end result is a rise in volume, then pressure has to be lowered. The fifth factor we have looked at is the catalyst, and we've said the catalyst is a substance which speeds up the rate of reaction without taking part in the chemical change. So, all catalyzed reactions are faster as compared to the uncatalyzed reactions. The sixth and final factor we have said affects the rate of reaction is light, and we have agreed that light is only effective in photoactive changes or processes like photosynthesis. So those are the factors affecting the rate of reaction. Thank you.